Welcome back, friends. So today I am back again with another different kind of limit problem. We oftenly called this kind of problem as sum of a function or infinite sums at infinity. As you people can see, the problem is something different from the traditional, and it have also appeared in the B.Stat entrance exam in 2008. So let's give this problem a try and then came back to see the solution. So let's begin. First of all, what we have to understand, this notation 2n, this simply means 2n choose n. Sometimes we write it like this, and we are quite familiar with this kind of notations from permutation combinations. And if you simply write these notations, it will become something like this. Now if we expand the first part, that is 2n factorial, it will become something like, say, 2n minus 1 dot 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 dot. There is something called n factorial, and after the n factorial, the next term will be this, and down below there are also 2n factorial, and this n factorial and this n factorial simply cancels out. So now we are left with simply these things. Let me write it somehow different to understand this thing. It occurs something like always dot 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 dot. Both the things are same, but just expanding the notations, nothing more. We can write these whole things in this notation too. And here this capital pi stands for the product, and this product ranges from the value of r varies from 1 to n, right? So here we have to simply put the value r equals to 1, then what we have, n plus 1 by 1. If we put r equals to 2, then we have n plus 1 by 1 into n plus 2 by 2, and that is how it follows. Now in our question we have to take log on both sides. So if we take log on both sides, this side is simple and it will become something like this. What about this side? This side, it will become something like this. First we have to take log on both sides, and now as we know that if we operate logs on products, then it will result us in sums. Then we can write this like this. It follows from this simple property of log. I am assuming the base is natural base. We have always known this formula or result, as you people can say, and this result is true for up to n variables, up to n numbers, and I am just using that thing, nothing more. Now we have to find our limit, that is infinite limit, and it follows something like this. Now, as our notations follows something like this, and now we have to find the sum. But wait, there is a problem. When we learn the definition of infinite sum, it follows something like this. Right? If we have to apply this definition in this case, then we have to make some little adjustments. If we adjust it, it will become something like this. Just watch. It will become something like this, right? Now, as per the definition, what we have to do, we have to simply integrate this function, and we have to substitute r by n as x. So if we integrate, we have to integrate this function, right? So now there is a challenge, as people may say, to integrate the log function, and it's quite difficult because we have to apply integration by parts. We have to integrate this function. Then let's begin. The first function, if we integrate it, the first function should be this one, say 1. If we integrate 1, then it will result in integrate dx, and the result will be x, and the log function will be similar, just stand there. And now we have to derivative, we have to find the derivative of this log function, and there is an x, there is dx. So if we do the whole job, it follows like something. What is the derivative? If you derivative, it simply becomes b, and then we have to derivative this whole thing. That is means 1 plus x by 4. If we simply apply the quotient rule of derivative, then it will become 2 or x, because this derivative, one derivative is 0 and x derivative is 1, so it is x always, and there is 1 plus x, because x derivative is 1, and we know there is always another x, and 30. Now we have to simply move forward with our integration. See, this x and this x cancels out, and then left us with a minus sign, and this minus become plus, and this x and this x in together cancel out this x. So we are simply left with this x, and the integration of this thing is quite simple. Yeah, it is simply log 1 plus x. It's quite easy. Now we have to do, and we have to put the limit, because the integration is somehow like this. So if we put the limit, in saying this line. So 1. If we put x equals to 1, so what happens? This will be the 1 and this will become log 2. So there is a log 2. This will again becomes a log. Now if we put 0, the first term will be 0 and this will become log 1 and eventually log 1 is also 0. So we are left with 2 log. So our problem starts with here 1 by 2 before. So our problem like is becomes 1 by 2 into 2 log. These 2 and these 2 cancels out and we are clearly left with log, and this is the answer. So if you people find this video useful, then please do support us.